projects. In this video, we are going to explain about a project titled Classification of Brain Disorders in RS-fMRI via local to global graph neural networks. In this study, we address the escalating prevalence of irreversible neurodevelopmental and neurodegenerative conditions like autism spectrum disorder and the Alzheimer's disease. Despite the advancement, the underlying cause and the neural mechanisms of these disorders remain enigmatic, posing a challenge in comprehending their impact on the human mental health and the behavior. Diagnostic method primarily reliant on the symptomatic observation and the clinical expertise, often risk misdiagnosis. To bridge this gap, we introduce the application of resting the state functional magnetic resonance imaging, a non-invasive technique capturing the brain activity to elucidate the cognitive function and the neural organization, notably the functional connectivity derived from RS-MFRI proves the invaluable for studying the area. Potentially reflecting the disruptions and the neural network integrity, we propose an innovative approach that harnesses the functional brain network and RS-fMRI data to facilitate the precise diagnosis of the brain disorder. And we introduce a novel approach, the local to global graph neural network aimed at precise brain disorder classification using functional brain network. Current methodologies often overlook non-imaging data linked to the subject and the inter-subject relationship, leading to inadequate analysis of disease-specific local brain regions and the biomarkers, thus affecting the classification accuracy. Our proposed LGGNN tackles this challenge by employing a dual-tier design, a local region of interest graph neural network to extract the feature from the local brain area and identify the biomarkers, and a global subject GNN to capture the subject relationship using the embeddings from the ROI GNN and the non-imaging data. Experimental results affirm the superior performance of LGGNN, setting a new benchmark and the brain disorder classification across the various evaluation metrics. This innovative framework paves the way for enhanced diagnostic accuracy and a deeper understanding of the brain disorder intricacies. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7, Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. And the first one is importing the package. Here we need to import the enabled functions like data manipulation, visualization, image processing, model building, and evaluation. And the second one is exploring the dataset. Exploration of RS-fMRI dataset is conducted. This stage involves analyzing the dataset structure, distribution, and the characteristics to inform the subsequent processing step. And the next one is image processing. Image processing techniques are applied to enhance the quality of the RS-fMRI data. These methods could involve the operation such as noise reduction, normalization, and the spatial filtering, enhancing the dataset for the subsequent analysis. And the next step is data extraction from the image. Relevant data is extracted from the RS-fMRI images. This could encompass the features like functional connectivity pattern and the brain region activation that play a role in the classification of the brain disorder. And the next step is data splitting to train and the test. The dataset is divided into the training and the testing subset. The training data is utilized to train the model, while the testing data remains unseen until the evaluation phase. And the next step is building the model. Here various models are built, and the first one is LGGNN, means of local to global graph neural network using the PyTorch. It is a specialized architecture developed using the PyTorch framework. It offers a unique solution to address the brain disorder classification by incorporating both the local and the global relationship within the functional brain network. The network captures the intricate pattern and dependencies among the different brain regions, contributing to more accurate and context-aware prediction. LGGNN leverage the graph neural network principles, making it adapt to the handling the data with the complex interactions. Its implementation and the PyTorch facilitate the efficient training and optimization too. And the next one is GAT, Graph Attention Network using the PyTorch. It is constructed using the PyTorch framework. GAT specializes in capturing the attention-based relationship within the complex data structure, such as the functional brain network. By assigning the varying levels of importance to the different connections, GAT excels at highlighting the relevant interactions and the features for the brain disorder classification. Its PyTorch implementation ensures the flexibility and of efficient training. And the next one is Inception. It is a renowned deep neural network architecture known for its ability to efficiently capture the multi-scale feature. And this project, Inception, is employed to extract the intricate pattern and the characteristics from the RS-fMRI images. Its hierarchical structure and the parallel processing of the multiple filter sizes enhance its capacity to discern the relevant spatial features, contributing to the accurate brain disorder classification. And the next step is exception. It is an extension of the Inception architecture, focusing on factorizing the convolutional filter to enhance the learning efficiency. Applied to this project, it further refines the feature extraction from the RS fMRI data. And the next one is DNN. Deep neural network is a versatile model that can be tailored for the various tasks, and this context a DNN is designed to uncover the complex relationship within the RS fMRI data. Its multi-layer structure and the non-linear activations facilitate the representation of intricate functional connectivity patterns, contributing to the robust brain disorder classification. And the next one is Ridge Classifier. It is a linear classification algorithm that introduces the L2 regularization. It is employed to compare the performance of the traditional machine learning method with a more complex model. Ridge classifiers simplify the classification task while controlling the overfitting, making it a benchmark for assessing the effectiveness of the advanced approach and the project. And the next one is SPM. It stands for Support Vector Mission, is a powerful and versatile classifier well suited for the binary classification task. In this project, SPM leverages its ability to identify the decision boundaries by mapping the data points into a higher dimensional space. It excels at discerning the complex relationship within the RS fMRI data. And the next one is Random Forest. It is an ensemble learning method that combines the multiple decision tree to enhance the predictive accuracy. In this project, Random Forest leverages its capacity to capture the non-linear relationship and the interaction among the features, making it suitable for extracting the informative pattern from the RS fMRI data and enabling the robust brain disorder classification. And the next one is voting classifier. It combines the prediction from the multiple models to make the final decision. It plays a pivotal role in the project by aggregating the output from the various classifiers, including LGGNN, GAT, Inception, Aspiration, DNN, Ridge Classifier, SPM, and the Random Forest. And the next step is user gives the input. A user-friendly interface using the Flash allows the user to input the relevant data with the brain disorder prediction. And the next step is the given input is pre-processed for prediction. The provided user input undergoes the pre-processing, including the feature extraction and the formatting, to ensure the compatibility with the prediction model. And the next step is trained model is used for the prediction. The trained model analyzes the pre-processed input to predict the likelihood of the specific brain disorder based on the extracted features and the learned pattern. And the next one is of final outcome is displayed. The prediction outcome is presented to the user through the Flask interface. This outcome includes the information about the predicted brain disorder, contributing to the informed decision and the potential clinical application. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. And the folder containing of the training and the testing folders containing of various images within each folder. And in the same way for the sample folder containing of various folders within each containing of various images within it. And the static folder containing of the folders like of CSS, JavaScript, images and assets and the bootstrap files within it. And the template folder containing of the HTML documents typically include of graph, home, index, notebook, results, sign-in and sign-up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of the code, graph and output all in one place. It allows the user to write and execute the code and the Python script, and it will be used to allow the user to write it and make it a popular choice for the data science. And the model is an pickle file which contains the information of algorithm and loaded into the project code during the runtime to utilize the various tasks such as making the prediction on the new data, performing a specific operation. And the signup.db is a file that appears to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this, it will change the country directory to the code folder path. And then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we redirect it to the page containing of the title and the sign up buttons. Then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of username and password, and those details we need to be filled. And then click on the login button. Here it will redirect to the index file containing of the choose file and upload buttons. Then click on the choose file button. Here it contains of various images within it, and we need to select any one of the image and then click on the open button and then click on the upload button. Here the uploaded image is predicted as having the diagnosis with early mild cognitive impairment. And by clicking on the try again button, we redirect back to this index file, and by clicking on the choose file button, here we can select the another image and then click on open button and then click on upload button. Here it predicted as of uploaded image have the diagnosis with mild Alzheimer's disease. In this way, we can predict the disease by using this fMRI images. And in conclusion, we summarize the proposed method for classification of the brain disorder using the functional brain network and RS-fMRI. This project proposes a new GNN framework, namely LGGNN, for classifying the brain disorder. The LGGNN is mainly composed of two GNNs, a local ROI-GNN based on the regional brain graph, which learns and analyzes the feature of the local brain region to identify the biomarkers, and the global subject GNN, which encodes the non-imaging information to learn the relationship between the multiple objects with the feature embeddings generated by the local ROI-GNN. This experimental result over two public datasets demonstrate that LGGNN that take advantage of the two types of GNNs achieve the state-of-art performance.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.